Wow, look at this, guys, a 1979 or 1980s cocktail Space Invaders machine. Now this one's a slight variant of Space Invaders. This one's called Moonbase by Nichibusu, I think that's how you pronounce it. And it's pretty much exactly the same game as Space Invaders, apart from there's a couple of minor graphics changes. I think the main base that you move along at the bottom, like the player character, is slightly different. And I think possibly the UFO might be slightly different graphics. But apart from that, it's an exact clone of Taito Space Invaders and licensed by Taito as well. Let's lift the lid and we'll have a look inside. Now, there is no logic board in here, which actually goes there, and that's the main brains of the game. I've actually got that over the house at the moment, so we'll have a look. We'll probably have a look at that first, I think. And then we might move on to the black and white monitor. That'll probably need recapped. And we've got the linear power supply, which is down there as well. So that'll be the electrical side of it, but then there's a lot of cosmetic details that need addressed as well. So I'll just show you what I mean. I'll just go down to the control panel. So if you notice, we've got things like all of the blacks came off on the metal work here. So I bought myself a powder coating gun, so I'm planning on taking all of this apart, re-powder coating it all to sort that out. Also things like the button here is all faded, so we could do the replacement button here. And the joystick itself keeps sticking, it's not actually working correctly, as you can see there. And it's pretty much the same on the other control panel on the other side as well. And we've got things like the coin box here is all rusty and corroded, and the same with all of the legs down here. Now I did price up to get those re-chromed, but it was an absolute fortune, so I'm going to try and powder coat those with some chrome paint instead. And the same on this side, if you notice they're all corroded as well. All of these corners are all corroded, so they're going to need addressed as well. And if we look at the glass here, it's got a lot of deep scratches all over it. Now I'm not sure whether I can do anything with that, whether I can try and polish that out perhaps or not, I don't know. But we'll try and address that as well. You see the corner on this one as well is all corroded and rusty as well. So I don't know what other problems it's going to have. Like I say, I don't know whether the tube actually works in this. It's actually a black and white monitor that's in this. So it's actually the original black and white CRT that it's got in here. You can see some of the screen burn in the tube there. And it's got the colour overlays on the glass here that give it the appearance of colour. That's how they used to do it back in those days. So I saw this on eBay for spares or repair, and I paid just over £230 for it. I bought it off a guy called Tim, and he actually had two of these. And the circuit board is out of the other unit that he had, but he converted that one to main because this unit didn't actually come with a circuit board. So let's see if we can make it work. So I thought I'd bring the main logic boards over to the bench here so we can have a quick look at them. Now there's 3 boards in this module here. We've got the top board which does the sound, and this part here, it does the input and what's called the bit shifter, which I think is responsible for the smooth animation across the screen. The next board we've got down is the CPU board, which, as its name suggests, has the CPU, and it's got the RAM on it and a few other logic chips on it. And at the bottom here, what we've got is the ROM board, which holds the actual game programs. A bit rusty this as well. And one other thing that I've noticed is the serial number here doesn't correspond with the serial number on the board. Like I said, this came out of the other unit that Tim had that was configured with the colour monitor, and the one I've got is the black and white monitor. So whether or not there's any differences in the way it's configured, I'm not sure yet, but I'm sure we'll find out. So for testing purposes, I'm going to have to try and power this board up and connect it to a monitor somehow. So I do have the pin out of it here. So we need to supply a 12 volt, a 5 volt, a minus 5 volts, and then we'll have to feed the black and white video signal here into a monitor. Now, Tim did give me the wiring harness of the old machine that he converted to MAME. So what I'm going to try and do is hook this up to probably a PC power supply that's got the appropriate voltages on, and we'll see if we can power it up here in the little workshop here. Now, the only problem that I've got is I don't think I'm going to be able to have these 3 boards spread out across my bench and have a monitor and everything all set up, because my bench on my desk here just isn't really big enough. So I might have to do this on the floor. So I shall start sorting some wiring out, wire up a power supply, sort a monitor out, and then we'll see whether this board works or not, or whether it's got problems. And I've got a feeling it's going to have problems. Right, so what I've got here then, I've got the main logic board. That's wired up to the original power supply there, but I'm just using that for the connection, so I didn't have to butcher the actual harness up here. What I've done, I've just soldered the wires onto the bottom of this circuit board, onto the bottom of these plugs here. So I'm not actually using this power supply, plus a transistor just fell off it there. Well, that's another story. I've got a little speaker hooked up. That's the credit board. And I've got a monitor hooked up as well. So I just need to power up the power supply now. And we'll see what happens. I'll switch this monitor on. And I'll just go on to AV. I better plug the video signal in as well, might help. Right. Well, we do have something going on. But it doesn't look right. So it looks like we've got the same text printed all the way down the screen there. Now it's just gone off. Oh, and it's came back on. So I don't know whether that's just crashed and rebooted or not. So I think I'm going to have a look at the schematics of this. Now, luckily, Tim did give me the schematics for it. So I'm going to have a look over all of this lot and see if I can figure out what the problem is. But it actually looks like it's processing, because there's stuff happening on the screen, so it is drawing the screen, and it does appear to be processing, so at least it's not just totally dead. Right, I'm going to have a look over these schematics then, just to see what I can figure out. So this is the schematic of the ROM board, and it's also the same board that generates the video signal. So I've just been having a quick look over this, so I'll just try and get the camera set up a bit better so you can see. And I'll show you where I think the problem might be. So what we've got here, we've got a crystal that generates a 19.968 megahertz clock, which then gets fed into this chip here. And similar to the Defender arcade game that I looked at, it's got 4 74161 binary counters. So it looks like 2 of them do the Y on the screen, and 2 of them do the X on the screen. So we've got 8 bits each. So in theory, that's a resolution of 256 across and 256 pixels down. So what looks like is happening on the screen is we're getting the same 16 lines repeated over and over again. So if this does, let's say, lines naught or bits on the y-axis of 0 to 3, if all of those are on, that's 16, and then what it should do is tell this next IC to count up by 1, and then would be on line 17. So you sort of get the idea. So this does the first 4 bits, and this does the second lot of 4 bits. And it goes through some buffers and that and stuff. And then it eventually ends up down here, after it goes through a few logic gates and that and stuff. I think they're to generate the sync pulses. And then the video signal comes out here. It also reads, obviously, the pixel data from the RAM, which seems to be on these pins here. I mean, I'm just roughly guessing how it works. I mean, you know, I haven't studied this too much yet. So I've got a feeling the problem's going to be around here. This IC here, possibly. So what I think I'll do is I'll get the scope hooked up, and we'll see if these bits are toggling. And we'll see if these bits are toggling as well. They seem to be going straight to the other board. But then these bits, for some reason, seem to be going through all of this and through this other counter here, and then they give out signals M1, M2, M3, M4, which then go to the next board as well. So it could possibly be that the problem's on the next board as well, I don't know. So I think the best thing to do is going to start here, and then we'll just start tracing through and see if we get signals all the way through to the next board. So I'm going to hook the scope up, and we'll just see how we get on. Right then, I'm using the Finersi DPO 350p scope here, because it's a bit easier than getting my scope off the bench and dragging it on the floor here. So I thought I'd use this one just to give it a try. So the first thing that we need to do is look at, I'll just bring the circuit diagram up on the screen so you can see. So it's IC1F pins 11, 12, 13 and 14. So IC1F, so that'll be 10, so that'll be 11, 12, 13 and 14. There's a little bit of rust on this IC here as well. So I'm just going to power it on. So let's see what signals we get on these pins. Well, I'm getting a signal on there. I'm getting a signal on there. I'll see if I can adjust the time base on this scope. There we go. So 8, 9, 10. That was 11, 12. So we're getting all the signals there then. So it doesn't look like it is that chip. Now I don't know why I'm not getting anything on the screen now. Because we should have some kind of video output there. Just check all these connections plugged in properly. Oh, hold on. I don't think that one was plugged in properly. Right, let's just try that again. That's better. Okay, so we've got high score there now. So we're getting signals on all of those, so where does it go next from that chip? Actually, that's the one that seems to be working correctly. It's 1C. It's on the wrong chip there, so 1C. So hold on then. So 11. Yeah, well that's doing something. That looks a bit strange, that one. But we are getting signals on all of those 4 pins. So where does it go from 1C? So 2C pin 8. That's this pin. Right, so we're getting a signal there. 2C pin 11, 8, 9, 10, 11. So we're getting a signal there. 2C pin 3. So we're getting a signal there. And 2C pin 6. So that'll be that one there. And we're getting a signal there. Right, so not that then. So where does it go next? It looks like it goes to IC3C, which is this one here. So we should have an output on pin 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that looks a bit suspect. I should have an output on pin 15. And again, that looks a bit suspect. That's only about 2 volts or something. Right, what other pins should we be looking at? Pins 2 and 6. Again, that doesn't look quite right. And neither does that one. It's just mainly high all of the time. Let's check the signals going into this chip then. So they come in on pins number 1. So let's get back on the right chip again. 3C, number 1. Well, we're getting a signal going into there, as you can see. But we're not getting the correct signal coming out. The next one should be pin 3. We should have a good signal going in. And we do indeed have a signal going in there. So pin 8 should be the next one. And we've got a signal there. And then pin 15. Perhaps maybe in the wrong one there, hold on. Pin 10, sorry. And we've got a signal going in there. So we've got signals going into this chip, but we haven't got signals coming out of it. So I kind of suspect that chip. So one thing I thought I'd just try is to see what happens if we can put credits on it. So I found the 2 wires here that are for the credit or coin sort of slot. Well, that did something, because we've got a different image on the screen here now. And I think this is the player 1 controls here, so I've got a bit of solder here. I'm just going to try shorting out. I think this bottom one was ground. Well, it's doing something. I can hear some sounds, but I can hear like a saucer sound going in the background constantly as well. So I think there's problems with the sound as well on this, because some of those sounds didn't sound quite right. Like the shot sound there. I'm sure it doesn't sound like that normally. Let's see if I can put another credit on. And I couldn't hear any explosion sounds either. Let's just try that again. I think it was that one for shoot. Oh. And I think it's just crashed now as well. I think it's just reset itself. So I think this has got multiple problems by the sound of things. Let's just reboot it again there. Let's try putting another credit on. So that started it. And it's just reset again there. So yes, as I thought, multiple problems on this. So we've got a crashing problem, we've got a sound problem, we've got a video display problem so far. Excellent. So I brought the board back over to the bench, and what I'm planning on doing is removing the chip here. I'm just putting a socket in until the new chip arrives. And I think what I might do as well while I'm on is replace these electrolytic capacitors here, because we've got about 5 electrolytics that we could change as well, so we might as well do that while we're on. And also I might try removing the ROMs and just cleaning the legs on them, because some of them don't look in the best condition. It's like there might be a little bit corrosion on these legs here, which might be causing issues, I don't know. It looks like there's been some work done on this board in the past as well. Just looking at these ROM sockets here, it looks like those are being resoldered. Yeah, it looks like there's a few of them. Looks like that one doesn't look like it's been soldered, or that one, but it looks like the rest of them have. Now somebody said it was better to use the solder sucker with the board being vertical, because then you're not working against gravity, so I'm going to give that a try. Yes, it appears to be working. It looks like we've took a wire out there on that pin there. Hopefully that should be okay. Right, let's get this new socket in then. So you need 3 hands. Let's see if I can pop that socket up a second. Just to get a bit of solder on one of the pins. Right, that's a bit better. Right, that's the new socket in. And the weird thing is, when I've looked at the schematic as well, I don't know why they're using this chip, because it's a counter, but it's not actually being used as a counter. I think it's just being used as a buffer from the look of the schematic. I couldn't quite work it out. And one of the other things I've just noticed as well, I think it was one of these capacitors here. That was broken off as well. Right, I'm going to take these EPROMs out next and clean those. So I've just removed the first EPROM just to clean the legs here. And one of the things that I have noticed is somebody's put a socket in, but the notch of it is the wrong way around. Because there's a notch there, and on the PCB mask here. So put him back to front. Well, I've just cleaned this one, so I'll put this one back in. And then I'll continue doing the rest of them. So I've just removed this one. And I've noticed that one of the legs looks a bit bent here and a bit corroded. And one of them's actually got part of the leg missing. And it's the one that looks like it's being changed because it hasn't got the label on it like the rest of them. If you notice. These are 2708s, these EEPROMs, and my EEPROM programmer won't read them because it needs a -5 volts, a +12 volts, and a +5 volts for these to work. Because these are really old technology, these ones. So I don't know whether I can get hold of some 2716s and reconfigure the board to work with those, because they only take a 5 volts rather than a cocktail of voltages like these ones need. But we'll see. I'll clean this one up and we'll see how we'll get on, I think.
2 weeks later.
Well, I've managed to get hold of some replacement chips and I've finished changing the capacitors. And I've also changed 3 of the decoupling capacitors here, because 3 of those were snapped. I think there was one here, and one here. So let's get this IC in. Just got one here. And then we'll see if this makes any difference. Right, let's give it a try. Yes, was the board was face up. I was just checking I was plugging it in right. That's the only thing when you work on something and then you come back to it weeks later or a couple of weeks later. Right, I'm going to switch the monitor on. Now let's see what happens when we power it up. Right, here goes. So. Well, it didn't sound too good.
Another 2 weeks later.
Well, I've had a bit of a disaster with this one. So I remember that this board was that way up with the EEPROMs on the top when I was testing it with the scope. And over in this corner, we had the composite video output. But what I forgot I'd done is I'd turned this board over to have a look to see what chips could be gone on the sound side of things. So when I plugged these two boards together, I plugged that one into there, that one into there, and that's not the way it should be. This board should have been that way around, and that should have been plugged into there, and that should have been plugged into there. So what it's done, it's sent 12 volts, -5 volts all over the place where it shouldn't have. And it's probably damaged a fair few ICs, I would think. And one of them, which I know was definitely damaged, is this IC here. So I've ordered one of those. It's a chip I've never heard of before. It's a 75365. And it's a line driver. What it does, it gets the clock signal and it then uses 12 volts as a driver voltage and then sends it to the CPU and the RAM chips. Well, that's getting rather hot. So let's hope we haven't fried the RAM or the CPU. So this chip's just arrived. I had to order one from Germany because it's pretty much the only place I could find one. I did try France, but that got cancelled because apparently it was out of stock. So let's remove this, fit the new IC, and let's see what else is blown. Totally my own fault, so, you know, buck stops with me, I think. This is the new chip here that's just arrived from Germany. I ordered 2 just in case, because they seem to be quite rare to get a hold of now, these chips. So let's remove that one, we'll put a chip socket in, and we'll refit this, and we'll see what it does after that. Right, I've just put some fresh solder on there. Let's just see if we can get this chip removed now. see if this new socket will go in. Right, let's pop the new chip in. Right, let's plug this in and see what it does now. And we have no picture. So that's not good. So let's have a look at the schematic here. Let's try seeing if we're getting any signals on any chips. I just want to try on one of the ROM chips out of curiosity, just to see if we get anything. Actually, let's switch the scope on first, that might help. Doesn't look like we're getting any activity on any of the ROM chips there. So that's not good. Let's just see if we're getting any... Well, we're getting a clock signal there. So that's good, at least we're getting a clock signal out of that IC now. But we're not getting any activity on the ROM chips. And we're not getting any display, so we should have some kind of garbage on the display, I think, at least. So let's try these pins on. We'll try 1F. So we've got 11, 12, 13 and 14. So 1F is here. That's interesting. So there don't seem to be... We're getting some kind of signal there on that pin. It's only when I probe it with a scope that the picture seems to change there. So let's try 1C. Right, we've got a signal there. So we've got clocks on 1C. Let's try 1D. So on 1D, we're not getting signal on 14 or 13. So 1D definitely looks faulty. So I think we'll change that one next. Right, I've finished swapping the chip over. I've installed a new socket there. This is the 74161 binary counter. And interestingly enough, the original chip was a 7903. So I guess that's some kind of equivalent to the 74161. So we'll power it up now, we'll see what it does now. And we'll see if we get a picture. Right, let's plug the connector in. And let's power it up. We'll see if we get a picture. Oh, well, we've got something. Well, at least the processor and the RAM appears to be okay. But that still doesn't look quite right. It looks like we've only drawn half of the vertical. So I wonder if one of these counters is faulty still. So let's start with 1F. And if I not switch the scope on, it may help. So 1F. Right, so we've got something there, something there, something there, something there. So that one looks okay. 1C, something there. 1D we've just changed. Let's try 1E. We should be getting a pulse on that one, and we've only got a logic level of about 2.5 volts. So it looks like 1E's faulty as well. But at least we're actually getting something now, which is definitely an improvement. Right, let's see if I've got another 74161 somewhere, and we'll swap over 1E. So I've just finished swapping 1E over there, which is another 74161. I didn't have a new one, but I managed to find an old one, so let's go and try it now and see if it's made any difference. Right, got all the boards plugged in again, and I'm just about ready to power it up. So fingers crossed. Well, hey, that looks better. Oh, I was so gutted when this thing blew up. Well, that looks so far so good. You can see the Space Invaders and things and that there now. Let's just see if it continues in the demo mode there. Well, that doesn't look right, does it? So, it looks like we've fixed the problems on the top board here. So far anyway. And this looks like problems on the third board now, which is what's called the data shifter. And I know there's problems with the sound as well. So what the data shifter does is when it displays the Space Invaders, it's this part of the circuit that's responsible for moving the Space Invaders along smoothly. It's a bit like a sprite chip, let's say, or a sprite circuit. So let's just see what's going on again when it gets to that point. Now, interestingly enough, it looks like it's like the whole line that's faulty there. So I might try and put a credit on this. I don't remember which connections it was, so hold on. Right, we've got a credit now. So I think that's the one player start, so the inputs are working. And we've got some sound. Let's see if we can figure out that's fire. The sound still isn't right. So we'll move the ship along the bottom there. I don't know which one's left. I can move right, I've got fire. Now there's left. Right, so left and right are working. And I didn't hear a UFO sound come on there either, so there's problems with that. So I think we need to turn our attention now to the third board, which is the sound and the data shifter. So this is the data shifter circuit, which goes from here to here. I'm not sure what this bit does, possibly some kind of bank select or something maybe. And then we've got the data bits come in here, and then the data bits come out here. So it looks like we have I think it was about the first 3 rows were just all 1s. So it looks like those come to one of these chips here, the 74171. So that's chip 4D, 4C and 4B. So I'll get the scope out again and we'll have a probe around on these chips and we'll see if we've got any stuck data pins. Right, so I'm just going to put some credits on so the game automatically starts. I've got the 1 player input shorted out, so it'll start the game when there's credits there. So, right, let's see what we get on pins 2 and 5. Well, that doesn't look quite right. Let's just wait for it to start again. Yeah, that's not switching properly, that. We've only got, it's only switching like a tiny little bit of voltage there. It's just, yeah, that's 5 volts. So that one looks to be duff. And we've got 4C, which is this one here. Yeah, that looks better. Yeah, we've got signals on that one. But on this one, so it looks like we need to change that chip. And there's another chip that does the explosion sounds. Let's see if I can find that on the schematic. It's called Noise, which is this chip here, F7. And it takes a clock in on pin 3. And we should get an output on pin 10. So where's F7 here? So clock input on pin 3. Doesn't like we get any clock there. Actually pin 3 is here. Right, so we've got clock input there. And we should get an output on pin 10. And if you notice, we don't have any output on pin 10. So it looks like that chip's gone as well. So let's change F7 and D4, and then we'll see what happens after that. Well, I've just finished replacing 4D and F7. It's actually an interesting chip, this one. It's actually quite hard to come by now, the 4006. And what it is a static 18-bit shift register. And the way it's used here is we've got a chip, I think it's this one here, feeds it a clock pulse, which it then shifts. And the way the inputs and outputs are configured, it generates a random byte stream of 1s and 0s, which then gets fed to the speaker. A bit like when you used to tune your AM radio not to a station and you got the white noise like the shh, and that's what it gives out. And then that's fed into one of these chips here, which then gives the explosion sounds and the fire shot sound as well. So that's what that chip does. So we'll try it now and we'll see if we get the invaders displaying correctly, and we'll see if we've fixed the problem with the sound explosions, and we'll see what else is wrong with it. Right, just finished plugging it back together, so let's see what it does now then. Let's power it on. Right, let's put a credit on. Let's see if we get the invaders displaying correctly now. And we don't. They're better, but we still have a line through the middle of them. I wonder if the explosion sounds work. Let's see if we get... Yes. So let's see if we can figure out why we've got a line through the middle. I've got a feeling it's going to be the next chip down. So this is the chip that we've replaced, which does 765. So the next one down is going to be 4 on pin 5. So let's see if we get an output on that. Let's put another credit on. And let's go on to pin 5. 1, 2, 3, 4, 5. That did just flicker there. I would have thought we should see a lot more data shifting than what we're seeing. I might need to do a little bit more investigation on this one then. Well, I've been having a bit play around with this, and I think I might have found the problem. I'll just start a game there. And it looks like it's about halfway up on the graphics. So if I measure pin 5 on 5A, so we'll just go to 5A, pin 5. If we notice, it seems to be high. A lot of the time, if I measure pin 5 on the next one down, and if I start a game again, but notice it's pulsing there. If I go on this one, you see it's high a lot of the time. So I think it might be this chip that's at fault. Well, I've just finished replacing the 74151. Let's see if that cures the problem with the line through the invaders then. Right, let's give it a try. Let's put a credit on. Yay! Invaders with no lines. Excellent. Let's see if we can move around a bit. I can't remember which wire goes into the hole here. Well, the UFO hit sound worked, but we didn't have any sound of the UFO when it came on. So it looks like there's still a few problems with the sound on this. But at least it's mostly working now. So I think we've made good progress on this so far. Right, I'll have a look at see why the sound's not working on the UFO next. So the sound problems seem to stem from these chip sockets that these LM3900Ns are sitting in. Because if you move them, I was getting crackles on the speakers and things, so there's definitely bad connections on the chip sockets themselves. So what I'm planning on doing is replacing 1, 2, 3, 4, 5, 6, 7 of those, and probably the one that the amplifier sits in as well. So I think we'll come back once I've replaced all of those, and then we'll see if that's made any difference. Well, that took some doing. So the original sockets are what you call single leaf. So there's one of the sockets there. And what it does, it touches the inside of the leg here, or the outside of the leg, I'm not sure which way it goes. Whereas the ones I'm putting in the pin goes in between this side and that side, so these are called dual leaf. So it grabs both sides of the leg, so it makes a better contact. So hopefully that makes a difference. Right, I'll get those op amps put back in and then we'll give it a test. Right, I fitted the board, put the op amps back in, and I've also changed the output capacitor on the speaker here. So let's put a credit on and let's see if we get all the sounds now. Well, the UFO sound works. And the dump, 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 dump sound you can hear, that's actually a 555 timer and 4 resistors, and what it does, it selects a different resistor for each tone. Well, it's another sound effect that works, the UFO hit sound. So I think the only sound that I haven't tested is the one where you get an extra life, so I'll have to try that one a bit later once I get a bit better at the game. Plus I'm only playing it with buttons lying around on the floor here at the moment, so it's not the easiest game to play. So I think we'll call the motherboard fixed then for now, and we'll have to move on to the rest of the machine. So I've got the monitor to have a look at, there's the control panels and the power supply to look at. So we'll probably do that in part 2. So if you like this video so far, please don't forget to give it a big thumbs up and stay tuned for part 2. Thanks for watching.